stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Len Facchinetti, and let's write some code together, shall we? What we have on the menu today is a follower. And in case you haven't followed what I have been doing in this channel, we are doing a library to help you develop real-time audio effects for Reaper. And this library includes some graphical user interface functionalities, things like colors and spacing and so forth, the whole design system really. And also, we are implementing some basic algorithms that you need to process audio. And this really falls into the category of basic algorithms to manipulate audio. So let's first understand what is the problem that we are trying to fix. So I have here a track in which I'm going to drop a tone generator, which is a simple sine wave at -12 dB. Sounds good. Then let me put a gain effect that I developed way back. This is probably my first video of this series. No, it was not the first video. I think it was like the third video in the series of videos of me developing JSFX, developing these real-time audio processors for Reaper. So let's bring down the volume. And this is just a simple volume thing, right? So let's bring down the volume here. And I'm going to actually listen this time. It's not often that we listen to anything when developing audio effects. So let's hear this. Did you hear that? When I was moving this parameter around, I could hear clicks. Not that you know what you are listening for. Let's try this again. I'm going to play around with this slider that changes the volume. And I'm going to play around with this slider. It also changes the volume. Did you hear that? When I'm changing the volume, I hear clicks. When the volume is set at a certain dB gain, then it's fine. Doesn't change. Doesn't click. But when I start automating this parameter or just modulating this parameter or moving the parameter around, when I move this slider, I hear clicks. And that is what we are going to fix with a follower. Now, why is a click even happening in the first place? Let's actually try to reproduce this. So I'm muting this and pay attention to the clicks when I move the slider fast or when I move the slider more slowly. So of course it has to do with the rate of the change of the slider. Because when I change the slider fast, I hear clicks. And when the slider is moving more slowly, I don't hear clicks. And with this slider, I suppose I can move it as fast as I want, and it's never going to click. Right. So what I want is for this slider to behave more like this one. Let's look into the source code of this, and I will show you how it works, in case you haven't watched or you don't remember these videos from 1 year ago. So what's going on here is I have the slider, I have a conversion from dB into amplitude, or from dB into gain, or from dB into linear, however you want to think about this. And if you want to learn why this formula works and how this formula works, here are the links. They are the videos I keep mentioning from 1 year ago. And Bo is here. Hi Bo, great to have you here. And yes, sliders. Well, not just sliders, right? I mean, followers are going to be a solution for this particular problem that is caused by the slider. But really the problem can occur in other scenarios. The follower is just limiting the rate of change, as we are going to see. So it's useful in other contexts. Like, think of a tremolo, for instance, maybe. You probably wouldn't implement a tremolo this way. You would probably do an LFO. But the point is, there are other sources of signals that we want to have a follower on. Essentially, it's like a low-pass filter. We'll get to that. Okay, so the implementation of the plugin that has this kind of clicks, I think this, by the way, is what people call zipper noise. I'm not really sure, but I think it is. Right, so the way that this plugin works is we loop over the channels and then we multiply the samples coming in by the amplitude. Very simple. But the problem is that if this amplitude changes very fast, then we are changing this multiplier very fast. So suppose that the waveform is all nice and good at this height. And then I come here and I change the volume, and for a brief moment there is some, I don't think that I can actually hold at that point to show that, but at a brief moment there is going to be like a nosedive, distortion. The waveform is just going to go immediately up or immediately down, and that we hear as a click. If I guess one way of doing this is maybe if I assigned this to some MIDI control. And then I hold at exactly the right time, right? I think that would work. I'm not sure if I want to do that. How about I just try to automate this by showing track envelope. And then I can add a point here and a point there. Oh, this is continuous, isn't it? Just add another point. And I really need to learn how to work with automation in Reaper. I think I did it. As the playhead moves through here, yeah, immediate jump. So all I have to do is hold at exactly the right time. Yeah, I did it. Great. Oh no! Moving the playhead resets the oscilloscope. I didn't know that. All right, here we are, and I need to leave the playhead going. So this is the reason for the click. This discontinuity here, where we were multiplying by a number and then immediately we are multiplying by another number. This jump is a click. That's what it is. And that's what we are going to fix. And we are going to implement the simplest solution possible. Check this out. This is so neat. We can start to see the samples on the screen, and we can see the sample in which the change happened. Fun stuff. So we are trying to smooth this out. And the way that we are going to smooth this out is probably the simplest solution possible. We are just going to limit the rate of change of this value. So our little gain here can change from -1 to 1 immediately in one sample. We are going to say that no, you can only go at increments of like 0.01, let's say, per sample, or even something even lower than that. But the point is, it is going to try to reach the new value as I move the slider. It is going to, so right now it's -4. It's going to try to reach -20.5, but it's only allowed to get there in smaller steps. So limiting that rate. And if the parameter is moving around, maybe because you automated it, or maybe because you're just doing this, whatever the reason may be, or you assigned this to a MIDI pedal, then if you are moving around, then this is going to be our target. The slider is our target. It's where the gain wants to be. And we are going to have this follower that is trying to track the target, but it's going to lag behind, and it's going to have a limited rate of change. And if we do that correctly, we'll get rid of the zipper noise, the artifacts. In fact, there is already a plugin that we looked at yesterday that does this correctly, sample accurate automation. And even if you just add a new JSFX, if you go here and create new JSFX, let's call it like liafac remove JSFX. This is a gain knob. It comes with some sample code for you, just so if you are new to the language, then you see that there are different blocks and how to use sliders and that sort of thing. So if you just create a new JSFX, it's going to come with this boilerplate code. And this boilerplate is a gain control. We can move it around and we can see the gain changing. And let's hear this one to see if it has zipper noise, if it has that kind of noise. So we want to hear this one. Now, naturally, I will bring the volume way down and do this in small steps. Yeah, I don't hear any clicks. So what I did in one of my first live coding sessions 1 year ago was to implement this plugin so that I could explain the difference between linear and dB and how to go from one to the other. But I guess I started with code and then I broke it, because I started with this code and I got rid of it and started over. But the intent was to explain this formula, but I did not implement the follower part of the code that is implemented here. And we are going to implement it today as well. But I kind of broke the code. That's what I did. And that, as one does. And I don't hear zipper noise on this one. So it is doing that follower approach that I was explaining. Let's try to catch this one in the oscilloscope. Have my lovely tone. Not lovely, not really. Can I move this around? I really need to learn how to work with automation in Reaper. Let's get rid of that node, and it is going to be increasing for a little while. I don't think I want that. Man, how do I insert a point? Oh, it's there. There's a point there. You know what? I think I need to get rid of all these points and do it again, because I think it's moving slightly. We know that if the change is small, then it's not a big deal. Okay. And I think I want a little bit more room with these automation points, so I'll put them here. Okay, now I have flat line, and then a big jump. And then what I have to do is bring up the oscilloscope, make it smaller, and play and try to hold it. hang on, I don't see a change. Oh, I'm automating the wrong parameter, aren't I? Yeah, let's remove this. How do I remove this? I don't know how to remove this. I can bypass it. I guess if I remove the effect, it's going to remove the track. There you go. So I touch this, show track envelope, and then do the shenanigans again. Psh, psh, and bam. And now it is increasing. Great. To insert a point command and click, I don't think so. That is freehand, at least on my system, and I didn't change this modifier, so it's shift click for me, but whatever. So let's do this again. And let's chase that little guy. Come on. There you go. So you can see that the number is changing, the amplitude is not changing immediately. It is gradually changing. So there is a limit to the amount of change that can happen at any given sample. This period here. And this is so fast that you're not going to hear this as like, you're not going to hear this. This is so fast. This is like what, 100 samples, 200 samples, something like that. I guess it's 1,000 samples, actually. We'll get to that. I think it's 1,000 samples, and I'll show you why. So let's see how this is implemented. And I don't think I want to implement it this way, but let's see how it's implemented. I can stop the playhead now. So it's implemented like this. There is a block. The block runs every block. This is ridiculous. So there's this block here that is 1,024 samples. That is a buffer that we have to work on. And the block is going to run once every 1,024 samples. And what they are doing here on this code is they're calculating the D, or the difference in gain. So there is this slider that is the next gain. That's the target. And then there is the last gain. The last gain is our current gain. So we have two variables to keep track of. Our target, where the slider is, and the actual gain that is actually going to be multiplied by the samples. Actually computing the attenuation. And this is the target, this is the follower. And in the block, what they do is they take the difference between the next gain and the last gain. So where we want to be and where we currently are, this is the difference. This is the path. This is the distance we want to travel. And in our plugin, in our naive implementation that has noise, that is clicking, this is it. We just calculate this difference, and then we update immediately the gain that we are going to use using this difference. But here they don't do that. They divide this by the size of the sample block. So if you have 1,024 samples, the transition between the target and your current gain is going to happen in 1,024 samples. And that's good enough because you don't hear the click because the transition is smooth. What I do like about this is that it's relatively simple. What I don't like about this is that if the change in volume is super big, then this 1,024 samples may not be enough. Or maybe your buffer size, your size of your block is not 1,024, maybe it's like 64 because you want to have low latency. So you want 64. And then if you have 64 samples of block size and if your change in volume is very drastic, then it may produce artifacts. It may click. Now, I haven't really tested this to be able to measure it, to see if it really happens. But in theory, it kind of sounds wrong. What makes a click happen is when you are changing some parameters super fast. So, for instance, let's say that we are going from a gain is in amplitude. It's a linear thing. It's not in dB. So let's say that we are going from 0, which is complete silence, to let's say 2, which is doubling the amplitude, or I guess it's a 6 dB increase. 6 or 3 dB, I forget. I think it's a 6 dB. I can quickly check, can't I? What is 20 times the log 10 of 2? 6 dB. Yeah, I should probably know that by heart. But in any case, yeah, so it's, if we are going from 0 to 2, and we are in a small block size, because maybe we are tracking, so we want low latency. In that case, then the gain here may be jumping too fast, and we may hear a click. I think it would be better if, instead of depending on the block size, which is a nice hack, it's probably going to work most of the time. I haven't really tried, but I don't think it's easy to make this click happen. But what we can do is just slightly fade in. And the fade in is going to have a constant rate, and we are going to find a rate that works. So that's the difference. This is going to get to the target in the block size. So if we have 64 samples of block size, it's going to get to the target in 64 samples. And that may be more samples than necessary if the change is very small. And it may be more samples than necessary if this step is very small. And it may be not enough samples if the step is too large. And so I don't want to have that fixed length of the fade. So I guess I can explain this visually. So what we are going to do is essentially a fade, and it's going to be, I guess, a linear fade. That's what they do there. It's a linear fade, and we are going to do a linear fade as well. So in essence, what they have is they have a fixed length of the fade. So it moves around like this. And what I want to have instead is a fixed. So it doesn't matter if it's fading. Let's see. Oh, I cannot change the volume here on this one. So let me just bring some audio. So what they do is essentially a fade, and it's fading the same amount of time regardless of the fade change. And you can see that the slope of the fade is moving as I move the cursor, right? What I want to do instead is I want the slope of this fade to be constant, and I will change its length to compensate. So I don't think I can do that in a single move here in Reaper, but if the change in volume is greater, then I'm going to spread it out in time to keep the constant slope. I hope that this will be better. Definitely for the case of volume automation and for gain, it doesn't really matter all that much, I don't think. I haven't really tried. We'll see. We'll implement this together today. I don't think it matters that much. But for other things that you may want to have a follower on, that may be significant. And as I said, this is kind of a low-pass filter, because if the rate of change here is too great, we are fading it. We are not letting the rate of change be too great, too large. And you can think of this as a low-pass filter as well. And it's a kind of a cute low-pass filter because it's based on the slew rate, right? We are limiting the rate of change. So there you go. That's the theory. Let me remove this track. There is enough junk in there already. So now there is something interesting about the approach that I think I'm going to use to implement this. So let's look at the implementation of something else, like, let's say, the Rbj filters, right? These are low-pass, high-pass filters, that sort of thing. And This is typical of everything else that I'm implementing. I have a data structure and I keep around some parameters for this data structure. I keep around filter coefficients. I keep around previous values that passed through the filter because that's necessary to make the filter work. So usually the way I go about implementing something is I define some data structure and I store stuff in there. But I think that for the follower, I don't actually need that. So let's talk about why I have these data structures in the first place and why I may not need that in this particular scenario. The reason why I have data structures in the first place is that I need to store some values that I don't want to expose to the user of the library. So the person who is using a filter should configure the filter. So they should say that the filter is a low pass or if it's a peaking filter. And they should specify the queue and they should specify maybe the gain on the shelf, that sort of thing. They need to specify these parameters, but I don't want the user of the filter, the programmer using the library, I don't want them to have to keep track of the coefficients. I don't want them to have to keep track of the previous samples or the previous filter outputs. Because while these are necessary for the filter to work, they are not usable. They are not something that the user of the filter cares about. It's implementation detail of how the filter works. So I want to hide that from the user, and here the user being the developer using the library, not the person who is using Reaper and using the audio effect. So the purpose of these data structures is to hide the implementation details and the pieces of data that the user, the programmer, doesn't really need. That's the point of this. Now, this is all fun and games, but what happens if all the variables that you need are actually necessary? The developer is actually interested in all of them. There's nothing to hide. So I think that the follower is that case. Let's find somewhere convenient to start implementing the follower, and then we'll describe all the pieces of data that we need. Yeah, maybe it's going to be... It's not going to be a data structure, I don't think. So I think it's going to be more like around here, numerical functions. And I will implement a function that I will call follower. Not sure I love the name, but we'll start with that. So what are the pieces of the puzzle here? What do we need? Well, we need the value of the slider. We need the target, where we want to get at. We need to have, I guess, I don't know how to call this, but we need to have the value. I guess I'll call it current, or maybe I'll call it value. Yeah, the value is the current value, the one that is following the target. And then we need the maximum change. So that is going to determine the slope. If the maximum allowed change is large, then the slope is steep because we can go up very fast or go down very fast. And if the minimum change is small, then the slope is gentle. We are not allowed to move too quickly. And then how do we actually implement this? Well, we need to have, we'll probably need some local variables, so I'll define them here later. So what we need is the change that we want to make to the value. And note how we don't need anything else. This completely determines everything that we need. So the change that we want to apply to the value is equal to the distance that we want to travel but we want the minimum between that distance and the maximum change. So if this distance that we want to travel is less than the maximum change, that's what the minimum is going to return. But if this is bigger than the maximum change, then we return the maximum change. And then you just add that to the value, and there you have it. I don't think we need local variables at all. This, I think, is good enough for our purposes. So how about we define a volume plugin and use this follower, or maybe I'll add this to the demonstration effect. Yeah, I'll add this to the demonstration effect. Let's write some tests for this. Let's find the tests for the count trailing zeros and copy and replace count trailing zeros with follower. And then we probably need different test cases. So there we go. So let's say that our target is like 0.7. The slider is in a dB value that maps to 0.7. And then, oh, and that's another consideration actually. Do we want the follower to act on the dB domain or on the amplitude domain? That is significant. I think that we want to do it in the amplitude domain. I think that we want to do it in the linear domain. That's because I think that the click is related to the rate of change of the waveform linearly, not logarithmically. But I don't know. If we still hear clicks, then we can try it out to do it in the dB value. Okay, so that is our follower. And let's say that currently we are at 0.5. And let's say that we are allowed to go 0.3. So the result of this should be 0.7. We should reach the destination because we are allowed to make a 0.2 jump. Now let's reason about positive and negative values here, because I may need to do a bit more work to make sure that, yeah, in fact, that is the case. I need to do a bit more work to make sure that the sign is correct. So right now I have 0.7, 0.5, and 0.3. 0.7 minus 0.5 is 0.2. And the minimum between 0.2 and 0.3 is 0.2. So that one is going to pass, I suppose. Let's check. Pass, pass, pass. Where is our... Where is our test? It is... What is it called? It's called follower. It is here, and it's passing. Great. So now let's think about the case where we want to go from 0.5 to 0.7. And then I think that the signal is going to... First of all, what is the expected result? We expect to get there. You know what? I think that I want to reverse these arguments. I want to go from... value to target. Yeah. Source and target. Should I call this the source? Or should I call this the follower? Yeah, I think I'm gonna call it the follower. Makes sense, right? So the follower is the value, the guy that is lagging behind. So I am going to, of course, reverse this as well, though it's symmetric, right? Because of the way we read things. So if we are, the follower is 0.5 and the target is 0.7 and we are allowed to go at 0.3 increments, then that's gonna work. Now, for this other one, if I am at 0.7 and I want to go to 0.5 and the maximum change is 0.3, this is an absolute change. It can go up or it can go down by that much. In some cases, I think it would make sense to have the follower going up and going down, having different rates. So maybe when you're going up, you can go faster, and when you're going down, you can only go more slowly. That may make sense in terms of like how attack and release sometimes are different. But let's not get into that. So 0.7 minus, it's our follower. Let's have specific values here. The follower is currently 0.7. The target is 0.5. So our difference here is minus 0.2, which is the correct value. But the problem is, well, the minimum between minus 0.2 and 0.3 is still minus 0.2. But you can see where this is going to go wrong. But this test is still going to pass, just the way it's written. I hope. Yes, the tests are still passing. But you can see where this is going to go wrong really quickly, right? So if I am going from 0.5 to 0.7 and I can only go in steps of 0.1 and vice versa, I expect to arrive at 0.6 in both cases. Let's work through the logic this time. I think that the best way may be to just split the screen. So now let's consider this case where the follower is 0.5 and the target is 0.7. So we end up with 0.5 and 0.7. So the rate of change on this one is 0.2. And the maximum change in this case is 0.1. So we get the minimum between the two. That is 0.1. That's correct. But this last one is going to fail. So 0.7, the follower is 0.7, the target is 0.5, and the maximum allowed change is 0.1. So this is going to be minus 0.2, and the maximum change is 0.1. So this is going to be the 0.2 minus 0.2 is the minimum between these two numbers. So this is incorrect. So let's revise this logic. What I want essentially is to have the change that is the change, and I am going to have the limited change is the minimum between the absolute value of the change and the maximum change. And then the return is the follower plus the sign of the change. I'm not sure that sign is something in JSFX. I think it is. Times the limited change. Let's double check that sign is a thing. Yes, it is. So Let's work through the logic this time. The difference is still all right, then I am taking the absolute value of the change. So let's work through this case. 0.7. No, it's a 0.5 minus 0.7. So the change is minus 0.2. Let's have this change equals to minus 0.2. And then the limited change is 0.2, 0.1. So the limited change is 0.1, taking the absolute value. And then the sign of the change is negative times the limited change. And now we have local variables. There we go. Let's see if the tests are passing now. They are. Great. So I don't think I need a data structure. I could have a data structure for this that would remember like the rate of change or something, but then I would define this follower data structure in the init block, and I would set it up in the init block, and then I would use it in the like sample block, for instance. But there is nothing of interest. This value is just going to be somewhere else. This value could be right next to everything else that is happening, all the action. It could be in there. But and I need to get, I could just define this in the init block, but I find it better to just have it next to the action. And all the other values, I do need them. This is the slider one. This is going to be updating, so I need that. I need to keep track of that. There is nothing to hide. And this is the value that I'm actually going to use to multiply by the samples coming in the simple volume effect kind of thing. So I also need to have a hold of this value. So there's nothing here for me to abstract. There is no reason for me to have a data structure for this. So I think that's the story. You need to remove this one, right? And then there is a limited rate of change. Great. Let's develop a quick effect for this. I'll call this LeFac volume or gain. Yeah, I think this is good enough. And then the description is going to be this. And this is for real, you all. I think that this is going to be the actual first effect that we end up shipping. Fun stuff. I will need a slider that, for now, it's just going to be the gain or volume. Most of these other ones have volume in their name, so I think I want to have volume as the main name. But then, isn't it weird? I think that they have volume in their name. Oh no, it is called volume. So I'll call this the volume in dB, and this is a slider. And it is going to start at 0 dB. I don't make any change. And then there is the issue of range, and I will talk about this maybe not today, but I will talk about this at length later. But let's just have a range of 10 to 10 in steps of 0.1. Or maybe even that. And that is going to be the only slider for now. I will import my library. And I don't need an init block, but I do need a slider block. Yes, I will define a slider block in which I am going to have a slider volume linear. And I am planning on renaming this function. That's why I'm calling it linear here instead of amplitude. And this is that. Except that now I have to refer to this as the target. And then in the sample block, we are going to loop over channels, and we have so many of these loops that I might as well just copy the preamble from here. And yes, another difference between this and my plugin is that this is stereo and mine will be multi-channel. And there is a cost to this. The loop is slightly slower than copy and pasting code, but yeah, we always talk about that. So now all I do is I have a sample, or maybe even a slider volume linear target. Need to initialize this variable, don't I? So this is the follower. It is at 0 to begin with. Does that make sense? Yes, we were talking about amplitude here. So yeah, 0 makes sense. 0 is, or maybe 1. 1 is no change to the amplitude. Yeah. In fact, I think I can do it better and do it like this, because then this default is the same as this default. And it's kind of clear, I hope. Right, so now we can take the sample on that channel and multiply by the follower, the target, and the maximum change. That for now I would just set to something like it can only go, every sample, it can only go, let's say, minus 100. And I guess I can reason about it this way. This is the maximum step it can take in a single sample, minus 100 dB. So I guess any clicks that could happen would be at most at minus 100 dB in gain. Right? Right, so, well, I need to update the follower, so I don't think I can do it in a single line. Well, I could. I could just say it like this, but I find these kinds of lines weird. And I don't want to update this for every channel, so it goes like this. This is outside the loop. And this, I don't want to compute this every sample, so I'll just put this in the init block. And I will have a variable that I will call the maximum change. So I update the follower, and then I use the follower. And the person who has Cyrillic, the name of the person is written in Cyrillic, the Cyrillic alphabet, is here to say voom.ong in the chat. And I think that the proper answer to that is to report. But thanks for watching. Right, so is this all? Maybe. Let's see. And then I call this volume. It's not here. Did I create it somewhere wrong? No, it seems right. Do I need to refresh, maybe. Yes. Okay, goes from 10 to -10, and so let's put our sine wave and also our oscilloscope. And let's see if this is even making sense. Huh, it is making sense, but it's too slow, isn't it? Yeah, moving that. Only -100 dB per sample is not fast enough. I could have a slider for this, but I won't. I'm just going to tune it by trial and error, so an amplitude of -10 dB. But you can already tell that it's working, right? No, it's not. Oh, it is. It is working. It's just very slow. Let's try again. Okay, so now it's moving relatively faster. I'm not sure if it's fast enough, but it is faster. 10 times faster, probably. If I do it like this, goes almost immediately. Yeah, so now let's try the trick again where we automate this parameter. Param, show track envelope, and then embarrass yourself. Doesn't really matter if it goes from low to high or vice versa, but I'm going to make it go from low to high. And then show the oscilloscope, and let's see if it is doing the right thing. It is. And then let's try to hold at that exact point. And then travel back in time. Oh no, it is spiking. So I think that -10 dB is too little, -100 is too much. How about instead of just trial and error, we try to compute something that makes more sense? We reason about this and come up with a number that makes more sense. What is... no, okay. Yeah, I think we just have to tune this. I want to play around with this in the debugger. So we have here our follower and target. We can see that they are the same number. And as I move the slider, they always end up being the same number. What if I come here and change this to -100 and save? And we can see the follower catching up. But it's too slow. So let's do the mathematics and come up with a good number for this. Let's say that we are going from -10 to 10 dB. So it's a 20 dB difference. How much is 20 dB in amplitude? It's 10. So we want to take a step of 10 in, let's say, 1024 samples. That is that number. It's 0.01, essentially, rounding up. 0.01. So what is amplitude 2 dB of 0.01? Minus 40 dB. So it seems like minus 40 may be a good value for this. So now let's see again in the oscilloscope. This is going to be tuned right if the changes that happen in the oscilloscope are fast enough. They seem to be. But let's do the automation thing and see if it doesn't look like it's clicking. Now, we should see a difference here that if I went from here to there, it should take 1024 samples. So let's say that we start at, oh man, I need to learn how to use this. And you get out of the way. Thanks. So it goes from minus 10, and I will put another one here so that it is at minus 10. And this one is going to be at 10. It's going to jump from minus 10 to 10, am I right? Great. And then in the oscilloscope, ha! Got it first try. And yes, there is a bit of a slope here, and this slope is probably good enough. There is definitely no immediate jump. There is a slope. And this slope, the angle of this slope is the same regardless of the amount of change. Great. Let's hear this and check if we have zipper noise. So how do I turn this off? I think that if I do this, I'm allowed to change the parameter, right? Because if I have this, then I'm not allowed to change the parameter. But now I am, okay. Okay, signal is coming through. I still hear clicks. Do you hear clicks? I hear it. So minus 40 is not good enough. We need to be a little bit slower. Let's try minus 50. I kind of still hear something, so we are gonna jump to minus 60. Let's just play with minus 100 for a moment. That's too much. Let's do 60. Or maybe let's go the other way around. Let's do it so that When we get a fast enough response, we stop. Yeah, I'm doing this in the amplitude, so the dB value is moving in a weird way, right? It's moving logarithmically, so maybe I should do this on the dB value. Yeah, the point here is that I want this to be as small of a number as possible, because smaller means faster, but I don't want it to be so small that it clicks. I think that something around 70 might be the best. Let's play around with the other one. No, not this one. Isn't this interesting? Oh, I was gonna say, isn't this interesting? It goes up a lot faster than it goes down, but that's because of the ballistics of the peak meter itself. Yeah, so I want it to go about as fast as this. Well, I don't know actually. We need to test because this may be producing an artifact. And this is probably gonna get a bit loud. Okay. With 10, I hear a click, and with 50, I don't. I hear a click. And then I don't. So I'm gonna go with 40. And then I'm safe. Yeah, I think that with 40, I definitely don't hear a click. And the coolest thing is that I'm making a big jump to make it the worst case, but not in our, right? In our plugin, it is going to smoothly get there. While in this one, it could click if I made a big enough jump. I may be biased, but I think that I hear a bigger... So ideally, we don't hear a click, and we don't hear a ramp when I'm doing this test. Ideally, of course, it doesn't click, so it cannot be small, so small that it will click. But we also don't want to hear a fade. If I do this movement, it should perceptually get there instantaneously. So I think I got it. I think mine is even better. It seems like I can get there a little bit faster, but I could like record the audio and then do a blind test. But I will not. I will not, because it looks good enough for me. And I think I get there even faster, maybe ever so slightly clicking, but not quite. And let's just play around with wiggling the thing. When I'm wiggling it around, I can hear zipper noise. With this one, I cannot. Well, it's also not active. There you go. Yeah, if I understand the physics of this situation here, is what I'm doing is I am pushing the click to this amplitude. That's why when it's 0, it's a loud click, and when it's a minus 100, it's a very, very inaudible click. It's not really a click at that point anymore. It's more like distortion of the original waveform. So I think that maybe 60 is good enough. 60 is the noise floor of some things, right? I think it's the noise floor of my audio interface when I am driving it the way that I am right now. Yeah, it's even worse than that. Okay, so if I'm pushing the click to minus 60, I can tell that I can probably say that it's safe enough of a value. If I go any higher than that, we probably start to hearing the ramp of the volume going up. Okay, enough tweaking this. I think that minus 60 is not a click that you can hear, and it is a value that doesn't sound like a ramp. I don't hear it fading into that value. So I'm gonna call it a day in terms of the follower. The follower is following and it is working. What follows is tomorrow I am going to return to the volume plugin and I will flash it out because I want the volume plugin to do many things that all the other volume plugins don't do. I want this to have a drop-down menu that will give me different ranges for the sliders, and I want even to have a custom range that I think it will be useful for a volume pedal. So if I assign this to a volume pedal, a MIDI volume pedal, I want to have control over the range. So let's talk about how to make a slider with customizable range. Now, of course, that's a feature that does not exist in JSFX, so we are going to hack our way around it. And that is what's up tomorrow. So for now, thanks for watching. Thanks, Bo, for being active on the chat. I hope that you all learned something from this. And yeah, this was followers. And if you like this, make sure that you follow. No, it's actually subscribe. Yeah, whatever. See you tomorrow. Have a good one. Bye. Oh no, my keyboard shortcut doesn't work. Let's try again. Bye.